Okay, so today we're going to look at quadratic written in factors. Remember, we've already looked at two different kinds of form, right? First unit was all about the vertex form, which you all hopefully remember, right?
Sorry for the interruption. This is an on-call for those who would like to register for the literacy test, the OSSLT. Please register today. Thank you.
Then we looked at the standard form, which we did not have a lot of information from the standard form, right? What's the only thing that you can actually find right away from the standard form?
Y-intercept.
The y-intercept, which is the C, right? The last letter. Remember that? Last number. And now we're going to talk a little bit more about the factored form and what can the factored form tell you.
Test is going to be on the vertex form, right?
The test is going to be on factoring,
Oh, so
doing the GCF, factor, sum and product, and the difference of
but
squares.
not the division stuff that we did yesterday.
Yes. And it's going to be on expanding.
This is going to be on it. So this is going to be on test.
Yeah. Okay? And it's also going to be the quiz. And it's going to also be on expanding. Remember the FOIL method?
Yeah.
Right? Alright. So let's look at this. This looks like the factored form, correct? Right? It looks like this, where you have the two brackets, and then x minus something, and then x plus something, or whatever, right? Okay, so this is the graph. Now we're gonna try to look at the graph, and then we're gonna try to find the zeros, and then we're gonna go back and relate. What are the zeros here?
2 and 1. Yeah, positive 2 and positive 1.
Negative 2 and negative 1, right?
Yeah, it says positive in the brackets.
That's right. Inside the brackets, it says positive, right? But graph, it's actually negative. Okay? We're going to talk about why there is a difference between the two when you're looking at inside the bracket and when you're looking at the graph. Okay? So, looking at the graph only right now, you can tell me that the zeros are negative 2 and negative 1, correct? Okay. So let's write that down. So the x-intercept or the zeros equal to negative 2 and negative 1. How about the y-intercept? So what is the y-intercept?
So then we have to put x-intercept 2 and
Equals, yeah, negative 2 and negative 1.
Negative 2 with points. We can't do points.
No. So if you want to do points, it will be like this, Brian. You can do points, but it will look like this. So it's going to be negative 2 comma 0
Yeah. That's what you said.
and negative 1
Oh,
comma.
that's why.
So you still gotta put that in
Yeah.
there, right?
Why would you find?
Because they're two different points,
Okay.
right? They're not one point. Okay? So you either pick this method or the other method. Okay?
Once we find them, as long as the 0 is in the points, you're good. Pretty much.
I don't get it.
Never mind.
Positive 2.
You mean as long as you don't just write 2 and
Yeah.
like just 1?
Yeah, it's not like
You have to either write x-intercept
2 and 1 or.
negative 2 and negative 1, or you have to write it as a point, and then the y value of the point is 0,
Yeah, that's
right?
what-
Because it's touching the x-axis.
That's what I was talking about. 2
Yeah.
and 0.
2.
Okay? The y-intercept is
2.
2. Yep. I'm just trying to make sure that it is actually 2. So the y-intercept is 2. Also, there's two ways that you can write this. So you can write it as y-intercept equals 2, or you can write it as a point, which is 0 comma 2.
So this one can be
Written either as y-intercept equals 2,
2, possibly 0, 0, possibly 2.
it's not those ways, it's cons. Okay, now, what is the vertex? I know it's not very clear, but I feel like it has to be in the middle between the two zeros, right? So it has to be at negative 1.5, right? Because it must be in the middle. So that's going to be about negative 1.5. And this looks like it's about negative a quarter, right? Because if half is right here, right? So it's at about 0.25. Okay? So I'm going to write it as negative 1.5 and negative 0.25. Now, what's your axis of symmetry? Negative 1.5. Do I just write negative 1.5? I have to write x equals negative 1.5, right? Remember that this part represents your axis of symmetry. This part of the vertex, so the x value of the vertex, represents your axis of symmetry. Are you okay with this? Okay? How about the optimal value? Y equals negative 0.25, and that is the y value of the vertex. Okay?
Can you scroll up so I can see more?
Are you guys okay with this? So locating them on the graph. Now, let's look at the second graph. Can you guys tell me what the zeros are? 1 and negative 3. So if you look here, this is one of the zeros, so it's at 1. And you have this one, which is at negative 3.
Or I can just look at that and be like negative 3, comma 0, and negative 1. And
It will
then
be
0.
positive 1.
Well, yeah, opposite.
So you're looking at the equation,
That's
right?
how we use it.
That's how we're gonna have to learn how to do that.
Yeah, we can look at that
Okay?
and just-
So right now we're kind of correlating the equation to the graph. Okay? So you're a step ahead of us.
good thing or bad thing?
It's a good thing. Okay? Okay? So you're kind of looking at the equation and you're trying to find the zero from the equation.
Because most
We're-
things are in the equation.
most times we're gonna have an equation, not a graph. Okay? But I want you to see that if I graph this, my zeros are going to be the opposite of what you see inside the bracket.
Yeah, when you graph it.
When you graph it, the x-intercept is going to be at negative 3 and at 1. So it's the opposite of what you see. Okay? So that's why we see them at negative 3 and at 1. And I'll show you why. Okay? In a bit, we'll explain why is that. So the x-intercept, no, it's always enough. So the x-intercepts are negative 3 and 1. Or you can also write them in a different way. So you can write it as negative 3, 0, 1, 0. The x-intercept the x-intercept is 6. So you write, y-intercept equals 6. Or you can write it as 0, comma 6.
Correct.
Okay? Now, when we look at the vertex, what does the vertex look like? It's at 1 and 8. Right? It's at 1 and 8.
Yeah.
Negative 1.
Yep, it is negative 1. So where would the axis of symmetry be? X x equals -1, and the optimal value, y equals 8.
So you put
What?
2, 0, 1,
Are you guys okay with this? Alright. Now, if I'm going to look at the key features, and I'm going to look at the equation of the graphs, you've already kind of gave me the idea of what I'm looking for. So what key feature matches information given in the equation? The zeros, right? So the x-intercepts, or the y-intercepts, the optimal value, the vertex, I can't tell them right away from the equation, right? I have to do work to get them. However, the zeros are pretty obvious. I can get them from the equation. Okay? So, if you compare the equation of each graph to its key features, what information about the key features of the parabola can you take from this form of the equation?
Zero.
The zeros. So an equation in factored form, it's going to look like this. Y equals the A value, x minus s, x minus r. This is what we call the generalized formula of the factored form. It tells the location of the x-intercepts, or the zeros, they're the same thing. Now, in order for you to have the correct x-intercepts, you have to remove them out of the bracket. So what we do, we set each part of each bracket, we set it equal to 0, and we solve for x. Okay? So I'm going to show you an example here. So, what form is this? Factor. Right? Factor. Vertex would look like this.
Squared.
That's right. That's a vertex. Okay? This is factored form. What can I find from factored form?
Y.
The x-intercepts, or the zeros.
Yeah, my bad.
Okay? So what are my x-intercepts here?
2 and 1.
2 and
1. Yeah.
negative 1. How do I know that? I take this and I set it equal to 0. Bring it over, so x equals 2. Okay? I do the same thing for the other bracket. I set it equal to 0. Bring the plus 1 over, what does it become? What does it become when I bring it over?
Negative.
Negative 1. So these are my 2 zeros.
Wait, so when you got the x and the negative, why didn't it become positive 2?
I brought the negative 2 over, it becomes a positive 2. Okay? I brought the positive 1 over, it becomes a negative 1. Okay? So anytime you have the factored form, you can find the zeros, and you can find the zeros by doing this method. Okay?
Isn't it just the opposite?
It is the opposite, but sometimes if you have something that looks like this, what's your zero?
-1.
And it's not negative. And that's why you should bring it over, and then you divide by 2, so it's negative 1 over 2. So you see why I show you this method, and not only look at it and then say it's the opposite, because when we get into harder questions, you need to be able to know that method.
If it's in brackets like that, it's more clear.
Yeah, but what if I give you this? What are your zeros? It is in brackets.
Alright, if the x is only there.
Yeah, if it's only x and then minus or plus a number, then it's easy. Okay, it's the opposite. But whenever you have a coefficient for the x, then it's not easy anymore. Okay? Then you have to actually know the process. Make sense? Okay, now. So I just want you to write this down. Factored.
We can write this down?
Write this down, yeah. L C where the zeros are. Okay? So I can find, or in other words, I can find the zeros from the factor. Okay? Now, are you guys okay with this so far? Okay. Now remember, this question is not asking you to find the zeros. I just did this so I can show you how to find the zeros. What's this question asking? Put it in standard form. So to go from factored form to standard form, what do I do?
Divide the 3 by the 2 and 1, I think. Or times.
FOIL, expand. Okay? FOIL is the process, expand is the heading. Okay, so when the question is asking you to expand, you're doing FOIL. Okay? So factored form can be converted to standard form by expanding. Now to expand this, first thing you want to do is FOIL the brackets.
X and X, 2X.
X and X, so I leave the 3 outside.
Yep.
X times X is,
2X.
no,
Yeah,
X
you got
squared.
it, man.
X times 1, 1X. Negative 2 times X, and negative 2 times 1, negative 2. So first you want to do the brackets, then you want to multiply that 2 in and simplify. Okay? So now we're gonna, sorry, that 3 in. So now we're gonna distribute that 3 into the bracket.
3X.
3x squared
3X.
plus 3x
5X.
minus 6x
Whoops.
minus 6. You're multiplying, remember?
Got it.
Okay? So in this case, we distributed that 3 in. And then collect like terms. So it's going to be 3x squared minus 3x minus 6. Okay. What can I find from the factored form? The zeros. Factored zeros. Vertex, vertex. So, from the factored form, I can find the zeros. What can I find from the standard form? Y-intercept. Okay? If I want to go from factored to standard, what do I do? Expand. Which is the same thing as FOILing. If I want to go from standard to factored, what do I do? Factor. How many different ways of factoring do I have? 3. What are they?
Was it vertex?
No. How many
Factor?
different ways we learn to factor? GCF, sum and product,
Difference of squares.
difference of squares.
Yeah.
So to go from standard to factored, you have to factor, and then you can factor using GCF, sum and product, and for difference of squares. Guys, this is the big picture. Okay? This is basically the big picture. I can add to it the vertex form. Okay? So if I want to add to it the vertex form, we only learned one thing about the vertex form, how to go from vertex to standard. That's the only one that we learned. And that is expand. So anytime you want to go to the standard, you have to expand. Okay? There is no way that you can go right away from vertex to factored. It's impossible. There is a way to go from vertex to standard, but you guys don't learn it. And then from standard to factored. Okay? Now, vertex form. What can you tell about the vertex form? What does it tell you? What does it tell you? What does the vertex form tell you?
The vertex.
The vertex.
Yeah.
Or the vertex is what? Axis of symmetry
The ultimate value.
and the optimal value. Okay? Alright. Do you see the big picture here? Do you understand that big picture?
He taught us like 3 ways to expand: standard expand, factor expand. More. I look at that, it's like, wow, that's a lot. Yeah, they all click together. That's the worst part.
You know I'm recording.
I'm saying some facts.
Just making sure, like, I'm gonna have to move on.
Yeah.
Okay.
Back.
So, what equals negative 3x squared plus 24x minus 48? What form is that in?
Standard.
Standard. Excellent. Now they want you to factor to put the zeros, to find the zeros of the relation. So I have to put it in factored form. What is the first question you ask yourself? Do I have a GCF? Do I? What is it? Negative 3, because you have a negative in front of the x squared. Okay? Alright, so your GCF is negative 3. Good. So you're dividing every term by negative 3.
That's the factoring.
That's factoring. Well, at first, that's the top, the GCF.
Yeah, GCF factor, not factoring sum.
Not yet. So it's gonna have to be, I'm dividing by negative 3, sorry. So it's gonna be x squared. What's 24x divided by negative 3? Negative what?
7?
8x. What's negative 48 divided by negative 3? Positive 16, right? 19? No, 16.
I don't understand. Why did it go 16? Why did it turn into a positive, huh?
Why did it turn to a positive? Anyone can answer that? Negative divided by a negative makes a positive. You see? You have negative
Oh, okay.
divided by a negative, so that makes it a positive. Okay, now I took out my GCF. What is the next step? So, sum and product, that's right. Why did you choose sum and product? It's a trinomial, right? When it's a trinomial, that means I have 3 terms. 1, 2, 3. Trinomial, you can't do difference of squares. So you have to look at sum and product. Okay? So, multiply to what? Add to what?
16 multiplied to 85.
So multiply to 16, add to negative 8. Okay. B is negative, factors have to be negative. So what multiplies to 16? 4 and?
4.
Well, both of them are negative, right? So negative 4 and negative 4?
Yeah.
Okay? And they both equal to negative 8. That's x.
4 and 4.
Yeah. So I can write this as negative 3, bracket x minus 4, bracket x minus 4. Do we understand what's going on here? Because if we don't, we're in big trouble. Okay. Now, so what are your zeros?
4 and 4. Negative 4 and 4. Where's my 0?
What?
No.
What's your zero?
Negative 4 and 4. No.
It's positive 4.
Oh,
So
positive
for this
4,
one is 4.
She knew, remember when you said when you're graphing it, it's different.
How about the 0 for this one?
Positive, right?
It's also positive 4,
Okay,
right?
yeah, good.
So how many zeros do you technically have?
It's tricky.
It's 1. It's the same thing, right? So if I'm going to find the 0 here, which is at 4, right? And then the 0 is going to also be at 4, so you only have 1 0. So this is one of the cases where you would have, it should be open down. So you would have 1 0. How did I know it's open down?
I got the negative.
Negative in front of
The 3.
the 3. So the A is negative, right? And remember, negative goes and goes down. Hmm? So this is one of your cases where you will only have 1 0. Remember at the beginning I told you you'll have 3 cases. Right? How many zeros can you have at max?
2.
2. And then you can also have 1, or you can have no zeros. Right? So this is the case where you have 1 0 and it's x equals to 4. Are you guys okay with that?
Yeah.
Right? Okay.
No, actually. Every time she asks that.
Next one.
Oh, I know this one. The difference of squares.
Right away.
Vertex. It's a vertex form.
Actually, yeah, that can be a vertex form. You're correct. But I'm gonna count it as a standard form for now because sometimes you can. You write it's a difference of squares, but you forgot to ask yourself the first question. Do I have a greatest common factor? Because technically, 24 is not a perfect square. Neither is 6. So I can't do difference of squares yet.
Oh, you have to do that thing.
So what's my greatest common factor there?
Negative 6.
Okay, so y equals negative 6 and divide every term by negative 6.
Would it be negative 6 because the 24 has a negative in front of it?
Yes. Okay. So what's negative 24 divided by negative 6?
Negative 3.
4x squared. And then 6 divided by negative 6? Negative 1. Now, 4x squared is a squared term. 1 is a squared term. So I can use the difference of squares, right? Because both of my terms are squared, and plus I have a negative in between, right? So these are the two things that you have to check for. So, what does this factor do? 2x plus 1, 2x minus 1. X.
You square rooted that, right?
I square rooted the 4x squared, that gives me 2x.
Yeah.
I square rooted the 1, give me 1. Are we okay with that? So now, going back to your question, what are my zeros here? No. Remember? And this is why I want you to guys try to follow my steps where you actually do it. Okay? So, set it equal to 0. Right? Set it equal to 0. You have to bring the 1 over first, so what does it become? Negative 1. Then divide by 2. Do the same thing for the other factor. Okay? So 2x equals 1. Divide by 2. So it's going to be a half. So your two zeros are negative a half and positive a half. Which way is this graph going to open?
Down.
Good. Are we okay with this? Now, the next one. Factor y equals negative 4x squared plus 24x. First question. Greatest common factor. What is it?
4.
If I have it. 4, negative 4x. Why x? Why negative 4x?
Because it's the x.
There is an x in both.
Yeah.
You see that? You see that you have an x in both terms. In this case, I did not have an x in both terms, so I couldn't factor the x out. I was only able to factor the negative 6. Yeah? However, in this case, I have x in both. So I can factor a negative x out. Okay. What do I have leftovers? So what would it be? What's negative 4x squared divided by negative 4x?
Positive 1.
Plus 1 what?
X.
Right? The negative 4 and the negative 4 would cancel. X squared divided by x leaves me with an x. How about 24x divided by negative 4x? Negative 6. One x or x is the same.
Yeah.
Now here's the question. What are my zeros? So 6, I'm hearing 6. 6 is a 0, yeah?
An x. 1. No.
It's not 1.
Okay, 0 or negative 4.
Okay, let's look at this. So basically my two factors are this and this, right? Do you guys agree? So these are the two that I have to equal to 0. So I'm going to do this one because that's easy. X minus 6 equals 0. Bring this over, it becomes x equals 6, yeah? Are we okay with that? Bringing negative 6 over becomes positive 6. Now, this one, if I want to equal to 0, what do I have to do?
9.
Divide by negative 4, because this is a multiplication, right? So right here, there's a multiplication. So to bring the negative over, it's going to have to become division. So what's 0 divided by negative 4? And this is where most students don't get. Okay? They will get this one, but they will forget about this one.
So if there's only one bracket, it's always 0?
if you have an x outside, right? You can imagine this as being written like this. Right? But I don't have to write that 0. Yeah? This is the same thing as negative 4x times x minus 6. They're exactly the same thing. But I don't write it this way because that means nothing. Like, why would I write more terms? Okay? A lot of students will forget about the x equals 0. And they will end up with 1 0, which is wrong. Okay? In this case, I have 2 zeros. One of them is a 0, and the other one is a 6. Are we okay with this?
This time.
Hello.
Sorry to interrupt.